Hello everyone, welcome back. Today we are going to solve another problem from CP-31 sheet. So let's get started. Let's understand the problem first. So the problem saying we are given an integer array. There are only positive integer and we have to tell whether that array is good or not and what the condition for a array to be good or not. So the condition is if all the sum of two adjacent elements are equal to the same value, then we can call that array is good. And if it is good, we have to return yes, otherwise no. Okay, let's come here and understand problem again carefully. So the problem saying we are given a integer array and we have to tell whether that array is good or not. And what the condition? Condition is this: if let's call this b1, b2, b3 and so on, if there are other elements. So in that case, for this array to be good, it should follow this sum. If I take two adjacent element and sum, then its value should be another sum of two adjacent elements. Like this, if I take b1 and b2, its sum should be equal to b2 and b3. Okay, and its sum equal to b3 and b4. Let's correct here. b3 equal b4. Something like this. It should be all adjacent element sum should be same of throughout the array. If it follows, then we can call that array is good, otherwise not. Okay, here in question we are given one more thing. We can change order of element of the array. We don't have to follow this order. We can change elements order anyhow, anytime, and many times, but at the end we have to tell whether after changing the order whether it's possible for this array to follow this condition or not. If it follows this condition, then we can say it is good, otherwise not. Okay, take let's analyze this example and figure out whether this array is good or not. If I take this order, then my array will be not good. Why? Let's check. If let's sum this value, this two adjacent pair, its sum is equal to 2. Okay, its sum is equal to 2. And if I take this value, this adjacent pair sums, its sum is equal to 3. They are not same. The condition is all pairs should be same. All pair sums should be same. If I take this sum, this adjacent pair, it should be same. If I take this adjacent pair, it should be same. Means like this. But they are not same. But in problem, we are also given we can change the order. Let's try to change the order and check again. If I bring this to here in between them, now I have just changed the order, nothing else. Elements are remain same. There are two ones, one, two. I just have changed the order. Now let's compute again. If I take this two adjacent pair, its sum is equal to 3. So let's correct here. So its sum is equal to 3. And if I take this adjacent pair sum, its sum is again equal to 3. And this is only element in my array. So yeah, all element to follows this condition. In that case, I can say this array is good array, and I will return yes. Let's take another example. If I take this, let's take this example first. If I take this array, can we say it is good or not? No, because let's analyze it first. If I take this element, its sum is 5. If I take this element, its sum is 5. But if I take this element, its sum is equal to 6. So no, all pair are same. So in that case, it is not a good array. Even if I change the order, it will make no difference because yeah, we can check just if you think we should bring this here again, it should be same. If I even bring this here, it again it should still same. Here its sum is 5, its sum is 9, and its sum is 6. So now it's become even worse. All pair sums is different, but we want same. So this is not a good array even after changing the order. So for this we can return false. Let's analyze this problem also. Because with many example we can get better intuition of what's happening exactly. So if I take this example, it's clearly seems they are not going to same, because here its sum is equal to 5, its sum is equal to 6, its sum is equal to 6, its sum is equal to 6. So here pairs, not all pair sum is same. So in that case, it is not a good array. Even if I change the order of these two, here all element are 3. If I put this 2 here, it's again its sum is 5, its sum is also 5. But again for this its sum is 6, and for this array, for this adjacent pair, its sum is again 6. So some pair sum is 5, some 6, they are not same. So still it's not a good array. Again, if I put here, again, what's happened? It become 5, but here its sum is equal to 6. Its sum is equal to 6. So okay, with this now many of example, we have built some intuition. Let's understand the, now let's try to figure out the algorithm for this problem. Okay, so what we have observed so far, we have observed if B1 and B, if they want same, if B1 sum, B1 plus B2 sum want equal to B2 and B3 sum, in that case, what's happened? Here it is saying B1 and B2 and B2 and B3, if they want the same values, and even if I have another value, let's call B1, B2, B3. If I want B4, for now let's call B4. So if I want its sum again same, what should be there? Yeah, of course, it's equal to 2. Why? Because its sum is equal to 3. Its sum is equal to 3. So if I want again 3, I want 2. It's some, so in that case these four should be 2. So what we have understood, for B2 is here sharing. So with our basic mathematics we know here B1 should be equal to B3 if we want all pair same. Again, if I take this pair B2 B3, so in that case what I need, I need if their sum also same B2 B3 and B3 B4, in that case my B2 should be equal to B4. Okay. Yeah, this is the idea. So what we have understood, it is following a pattern, something like this. If something like this, x, y, let's call x, y. If I want, if here a third element, so what should be this value? It can be z. No. If it is z, my sum will never be same. So if I want this situation, I want b1 and b3 same. So I need to add here x. And again, what should become here? If I want x and y sums like this, so again, if I want another value, so what should be that value? A z or x or c? It must be a y, because this sum x y should be y x and y x. We know from the simple basic mathematics, x plus y always equal to y plus x. Order doesn't matter, but value should be same. Here x y and y x should be same value. Here x come first, then y, and here y come first, then x. But in some we know order doesn't matter, value matters. So if it is x and y, so here for this sum it should be y and x. For this x and y. So we have understood a pattern here. It is following a pattern like this. Okay, x and y and so on. If it is following this pattern, then only we can say this is a good array, otherwise we can't. So we have understood, in my array I need only 2 elements, only 2, not more than that. If it is more than that, for example in this case, here we have 3 type of element, 1, 4 and 5. No arrangement can make this array good, because their sum always be different, because here we are considering 2 pairs sum, isn't it? So for that I need only 2 elements. Yeah, we have understood. This is, let's analyze this problem. Yeah, we have understood we need two problems. We need two elements. Let's analyze this. Here we have two elements, 3 and 2, but still this can't make a good array. Why? What's the problem? The problem is the ratio. Here 3 is more times than 2. So 2 is not distributed equally. For this 3 there is no 2. For this 3 there is no 2. For this 3 it has 2. For this 3 it has 2. But for this 3 there is no 2. If there is someone like this, if there is a 2 also, and if there is 2 also, in that case I can say this can be a good array. Let's analyze this only. It is 5. It is 5, but here there is no 2. It's again makes 6 it, and again it's 5 and 5. So because of this, it's not becoming a good array. If I put 2 here, now it becomes a good array. So what we have understood here, ratio matters. Let's remove them. If let's analyze this. What the ratio? Here 3 is 4 times. Here 3 is 4 times, and 2 is 1 time. So ratio is like this. But if I want good array, so I have to add two arrays, two twos, here one and another here. Now my 2 becomes 3 times. So now it is making a good array. So what we have understood? We have understood ratio should be either same or the difference should be equal to 1, not more than that. Here 3 is 4 time and my 2 is 3 time and the difference is 1. So the difference should be only 1. If it is exceed that difference, if anyone become more time than another and their difference is more than that, in that case it will not be a good array. Let's take an example. In this case, let's increase number of 2's. Here now my 2 is how many times? 4 times. It is still become a valid array. It's still become a good array. If its difference is 0, here it is 5, 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 and it is 5. All pair is equal to 5. But the moment I increase, the ratio is equal to 0. Here, how many times? 2, how many times? 1, 2, 3, 4. Yeah, it is 0. But what happens if I increase 2 again? What's happened in that case? The ratio become my 2 appear 5 times and 3 become appear 4 times. Still, ratio difference is 1 and still it can be valid by some arrangement. If I bring this 3 here from here to here, it still managed to be a good array. So yeah, it is still working. But the moment I increase one more 2, now my 2 is 6 time and 3 is 4 time. Let's see. My 2 is let's call my 2 is 6 time and my 3 is 4 time. In that case, the difference is more than 1. Here it is 2. In that case, it can't be a good array by any number of order changing. Nothing matter here. You can try. Even if you try to bring this, it's become will not help. Even if you try to take this 3 from here to here in between them, then this 2 become 4 and other becomes 5. So that's the idea. So what we have understood, let's write here. First thing we have understood, there should be 2 elements, not more than that. If at any moment it become more than 2 elements in that array, we can immediately return this can't be a good array. So this is one condition. Another condition is their ratio should be their ratio difference their frequency difference should not be more than 1. If it is exceed, we can say it can't be make a good array. Okay, now what other thing? We have analyzed this test case, we have analyzed this test case. Let's analyze one last test case. What happens if in my array there are only one kind of element, something like this, 2, 2, 2, 2, 2, 2, 2, and so on. So is it a valid array? Yeah, it is a good array. Here the sum is 4, here the sum is 4, here the sum is 4, and so on. So the all adjacent pair sum is same for all the elements for all the elements in the array. So it's forming a good array. So this is true. So we have also understand there should be either 2 element or only one, not more than that. So there should be 2 element. If there is no 2 element, then there should be only one element. There should be only one element. So we have understood either should be 2 elements, either should be 2. So if it is there are only one element, in that case we can say it is a good array. But if it has 2 elements, we have to check this condition as well. So these are related. If my array has 2 elements, I have to check the frequency difference. If it is one element, then I can surely say it must form a good array. So till now we have understood the infusion idea algorithm. We have to just code it. So don't waste time. Without wasting any time, let's come here and start coding. So what I need to do, I have to first make a function for this. It's like this: public static void, not void. What we have to return? Let's come here and first see the problem statement. So we have to return a string, yes or no. Yes, then my array is a good array. Otherwise, no. Okay. And what's the input type? Input the first line telling the number of elements, and the second line of each test is telling the array. Okay. So let's come here again and start coding. Okay, so we we have to return a string. What we can call this is good array, is good array. We have to check. And what we need here, array simply, nothing else. Now what I will do, I will check how we will write our algorithm. Here I will take two elements, and I will track that. If I found another element, in that case I can say this can't be a good array. Okay, so I need two elements, E1, let's call E1. In E1 I will track one kind of element, one type of element, and another E I will track kind of element. For example, in E1 I will check E1 1, and in E2 I will check and it took any numbers. So here I will start, let's call E1 nothing but for first time let's call it integer, integer dot max value. For E2 we can for E2 let's call, for E2 it is also same. What else I need? I need a frequency count. I need to count the frequency of element, each element. So I will take a two variable C1, it will count frequency of E1. So let's start from 0, and for E2 I also need a C2 start from 0. Okay, now what I will do, I will iterate over my for loop like this, int E and array. Okay, and what I will do, I will simply ask if my C1 is equal to 0. What this saying is saying I haven't taken any element in E1. So for the first time I make E equal to E1. I assign E1 E. Whatever the first element I will call it E1. Else if E C2 else if not else if, let's call first for the first time I will assign it to E. I will assign it to E1 and increase its frequency by 1, because and what if for the next time, else if my E is again E1, in that case what I will do, simply I will simply increase my count, C1 count. For the next time, if I again appear C same element, for example 1, in that case I will increase. If for the next time again I will encounter 1, I just keep increasing my C1. Else if what if it is not a C1 element, then it would be C2 element. If it is not a E1 element, then it must be E2 element. So I will first check if I haven't taken any element of E2. In that case what I will do, I will simply assign E2 that element, E2 equal to E. Okay, E2 equal to E. Here, if it is if it is for the first time, I will assign to E1. If it is again equal to E1, in that case, I again assign, I keep counting. If it is not E1, so in that case, it will not go to, in this case, in this block, and it will come here. In that case, I will simply assign to E2 and increase its counting like this, C2. And for the next time, if it again come to like this, else if for the next time, if again my E equal to E2, in that case I simply increase my count. Otherwise, in else, what I will do, I simply return no. Why? You hope you got it. Here I am tracking for the first time I am assigning to E1. For the for the next time, if it is E1 type, I just increasing the count. If it is not E1, then it must be E2. For the first time I assign it to E2. From the next time, if it is type of E2, I just increasing the type. If it is not belonging to E1 first type, if it is not belonging to C type, then then it is the third element, third type, and we have understood that there should be only two type element, not more than that. So in that case, I can simply return no. RETURN. Without wasting any time, we will simply return. And here at last, what I will check, if it is only the one type element, if it is only one type element, if my array contains only one type element, for example 2, 2, 2, 2, so in that case what happened, only for the first time I assign it to E1, and for the next time I just keep increasing E1 count like this, E1 plus plus, it's never assigned to C2. So in that case my C2 count will never increase. So here I can simply ask if my C2 count is equal to 0, in that case it is only one type element. In my array there is only one type element. So in that case I can simply return yes, this can be a good array. So yes, like this. Otherwise what I have to check, I have count one type element, I have found another type element, but this is not enough. I have to check the difference as well, because what's happened, if there is only 1 2 and there is 4 3, in that case this can't make a good array. So I have to check difference. If how can I check? I need to check absolute difference, because anybody can be, any type can be more than that. So absolute abs, and what I will check, I will simply check if c1 minus c2 is greater than 1. What I will do? Tell me. Here I will return. I am going to write a ternary operation. So what's happened? If it is greater than 1, what I will return? Simply no. No should be like this. Otherwise, yes. I hope you got that. I'm simply checking if the difference is larger, more than 1. In that case, it can't be a good array. One type is more than another type, more than 2 times extra. So in that case, it is not following the pattern x y x y x y. So in that case, I can simply say no. Otherwise, yes. Yeah, we have written the algorithm correctly. Let's come here. Hope you understand. Here I am just using 2 elements to track the 2 elements only, and their count. Here I am just tracking for what I am here tracking the first type element, second type element, and if is there any other type element, I'm simply return no. If it is only one type element, I'm returning yes. If it is only 2 type element, but I am checking the difference. If it is more than 1, I'm returning no, otherwise yes. Here, what we have to do, we have to write a boilerplate code to check our to run our method in Codeforces. We have to read input from the input file ourselves. So let's, with the use of the scanner. So let's start reading. For that, I am not going to explain what I'm doing, because we have doing this same thing in every lecture. So here system dot in. Okay, now for the first time, I will take the number of test cases for my file. In file, the first line contains the number of test cases. So simply I can do like this. Int next. Okay, now what I will do, let's first check if it is working or not. Yeah, it's working. Yeah, what I will do, I start a while loop, and for each test case until my test case n, for each test case, what I need, first line giving me the length of the array. For that, what I can simply take like this. Okay, now I need to form an array. So what I will do, like I will first create an array in type of length n and start forming. For forming, I need a in variable I. I run variable until my I is less than n. And for each array, for each I, for at every index, what I will do, I read from the file and write here like this. Once I form my array, I simply call my function is good array, and I will simply pass my array, and I need to print. So simply write system.out.print ln, and what I can do, I can simply write like this. Yeah, I have written the whole algorithm. Yeah, let's quickly copy the code and come here and paste here. Remember this problem number, because we have to write the problem number. So it is 1890A. Let's come here in submit section. It is 1890A problem, and we will simply copy paste our code like this, and we can submit now. Yeah, it's got accepted. So idea was correct, algorithm was correct. So yeah, this is the algorithm for this problem. If you like the explanation, please consider to like my video, subscribe my channel, and please do comment whatever you feel. Thank you so much for watching.